Hey everybody, I'm back. Still talking about functions here, and now we're going to evaluate a function. And this is again just talking about the notation, which is just so much more informative than just using y equals x squared minus 6x plus 8. Saying g of x equals x squared minus 6x plus 8 just tells us so much more. So we're letting g, we're calling this function g, be the function defined by the equation y equals x squared minus 6x plus 8. And y and g are interchangeable, but I like g. So g of 3 is telling me find the output of the function g when the input is the number 3. So I'm going to put g of 3 is going to be 3 squared minus 6 times 3 plus 8. So everywhere that there was an x, which is the input variable, I put a 3. I'm evaluating this. So this gives me, and notice I put parentheses around the 3 everywhere I substituted in for x. That gives me 9 minus 18, which is negative 9, plus 8, and that gives me negative 1. And I apologize in advance if I mess up some arithmetic thing in this course. My arithmetic is actually pretty bad. And so if I'm making a mistake like that, you can email me and let me know that the mistake was made, but hopefully the underlying idea behind this is the important part. So knowing that you should be plugging 3 into here is the most important part. You will have a calculator to help you through all these calculations if you need it. I think I have a calculator around here. I will be showing you how to use the calculator for certain things in this course, especially when we get to exponentials. And in those cases, I'll even give you a video on how to use the calculator. So if you have your TI-83, 84 series calculator, you'll be good to go. All right, so this is g of 3 is negative 1. That's the value. This equals negative 1. And more so, this is an ordered pair on the graph. So if I wanted to plot this point on the graph, the point would be at 3 comma negative 1. That's where I would find it. So when I'm asking what g of 3 is, it has more than one meaning. It's the output value of this function, but it's also the location on the graph for this function that I would find the point. So now let's find g of 2. Do that in a different color. G of negative 2, sorry. So this is going to give me negative 2 squared minus 6 times negative 2 plus 8. And even though I didn't put it in here, if you, at any point you wanted to pause and try to do these problems on your own and then unpause it and watch me go through it, that is up to you. So negative 2 squared is positive 4 plus 12 plus 8, and that's going to give me 16 plus another 8 is going to be 24. Now the last one here, let me do that in green. We have g of a plus 2. Now I'm allowed to plug anything into a function, even an entire expression. So this is an algebraic expression, a plus 2. And so everywhere I see that x, I'm going to put an a plus 2. Now this isn't going to give me a single number when I'm done. It's going to give me an algebraic expression in terms of a, and that's fine. G of a plus 2, I forgot the squared there. So notice a plus 2 squared is a plus 2 times a plus 2. So I need to distribute the a and the 2. So this is going to give me a squared plus 4a plus 4. If you distribute it correctly, this is what you should get from here. I'm also going to distribute the negative 6 through here, so that's going to give me negative 6a minus 12, and then I still have the plus 8. Okay, so I can combine like terms here. I still have an a squared, And then 4a minus 6a is negative 2a. And then we have 4 plus 8, which is 12, minus 12. That just gives me 0. So g of a plus 2 in the most simplified form is here. And I probably shouldn't have used the term simplified, because I would even argue that if you had written g of a plus 2 as a times a minus 2, I feel like this is simplified, but you might also just call this factored. But I think factored is simplified because it would be really easy to set this equal to 0 now and solve for a, 0 and 2, whereas this one I'd have to do a little bit more work to figure out what would make that equal 0. 0 is the obvious one, but I don't know that 2 would be as obvious as it is in this form, this factored form. All right. Well, that was fun, evaluating a function at various numbers and at an expression. And really this problem here with the a plus 2 is practice for what we're going to be doing later on in this lecture with average rate of change. All right, domain. When I think about domain, what I really think about are some red flags, okay? So the domain are all the values that I can put into a function that give me a value out, a real value out. And so the first red flag is I'm not allowed to divide by 0. So if I see a variable in the denominator, I'm going to have a red flag up in my mind thinking, ooh, there might be a value in this that if I plug it into this function, it's going to make me divide by 0, and that would not be part of the domain. Anything that makes it so you don't divide by 0 is okay for the domain, but if you divide by 0, that's bad. And so that number that makes you divide by 0 would not be part of the domain. The next red flag that I would look for is taking the even root of a negative number. So if I see a square root or a fourth root or a sixth root or so on, any even root, I would, and a variable underneath that, that would be a red flag for me, and I would say, oh, well, if I plug a negative number in here, I got to watch out for that. So these are the two main red flags that I'm going to look out for. Dividing by 0 and taking the even root of a negative number. And so looking at these problems, if I rewrite f of x as 1 over 1 plus x, 1 minus x, again, factored form makes it easier to see what would make me divide by 0. It looks like if I plugged negative 1 in for x or 1 in for x, I would divide by 0. And dividing by 0 is undefined. You cannot do it. It kills a unicorn, okay? That's why you don't see them in the wild. So we don't want to plug that number in. So the domain is going to be all the values that aren't those two values. So my domain for this function would be starting all the way as far left as I can think of, that's negative infinity, and we always don't include negative infinity because you can't reach it. You can't be equal to negative infinity. So we're going to go from negative infinity all the way to negative 1, and we're not going to include negative 1 either. So basically, if we think about the number line, this is what interval notation is really doing. We're starting as far left as we can think of, which is negative infinity. And then we're going all the way up, and we want to get to negative 1. But we want to skip negative 1. So not including negative 1 gets me all the way up to negative 1.000000000000001. I could keep doing that for a very long time. And then I'm going to pick up with a union here on the other side of negative 1. So I'm going to start including this stuff over here all the way until I get to 1. And then I'm going to union this starting on the other side of 1. So this got me up to 0.99999999999, and I want to skip over 1. So I want to put a hole here and a hole here, and then go all the way to infinity. So this would be the domain. in interval notation. I should have spread it out a little bit more. I'm actually going to do that. Let me rewrite this. It just looks bad. So the domain here would be from negative infinity to negative 1, union negative 1 to 1, union 1 to infinity, exclusive everywhere, okay? So negative 1 is skipped. That's what making this not include negative 1 on either side is skipping over negative 1. And this is skipping over 1 right here, okay? So the domain for f of x is all real numbers except for negative 1 and 1 is what that's saying. And if you want to write that out using words, you can, but if this is a multiple choice, they're not going to give you that as a choice. They're going to write it in interval notation. You should know interval notation. So now looking at g of x, I have a square root. Now I can't put any negative number in here, but I can put 0 in here. The square root of 0 is 0. And so I can include 0, and I can put any positive number all the way up into infinity, but I can't put anything less than 0 into this equation. So this is my domain from 0 to infinity. This was my domain for the first one. And for p of t, I'm not seeing any red flags here. I don't see a variable in the denominator. I don't see a square root anywhere or any even root. And so there are no red flags. And so the domain here is all real numbers. And this is how we write all real numbers using interval notation. All right, I will see you in the next video.